Hello and welcome to the second video in my series going over all of the physics that you need to know for the MCAT. In this video, we are going over the kinematics equations and things like velocity and acceleration. All of the things covered in these videos are teaching you the physics in a way that's preparing you for how the MCAT is going to test you on the information. If you like these videos, please check out my MCAT community through the link in my bio, where if you subscribe, you'll have access to over 500 pages worth of explanations and drawings over the highest yield Chem Phys and Biochem topics. We'll start out by talking about velocity and acceleration. Velocity is a measure of an object's displacement, which we will use delta x to show, divided by time. In physics classes, they really emphasize the difference between displacement and distance traveled. But the MCAT very rarely or almost never gives you problems that require you to really understand this distinction, so I'm not going to get into that in this video. So as bad as this sounds for a physics class, you're actually fine to treat velocity as the same thing as speed. And you're probably fine to treat displacement and distance as the same thing, but if you really want to know that distinction, there are so many good, quick YouTube videos on that topic. But real quick, if we say that we have an object and it travels from there to here, and we say that that was 10 meters, we would plug that into that part of the equation, and if this happened over a 2-second period, you would plug that into there, and then we would say that the velocity is equal to 10 meters divided by 2 seconds, which gives us a final velocity of 5 meters per second. Acceleration is equal to the change of velocity over time. This is one that is super simple, yet so many people get things wrong with acceleration. Everyone does seem to do a good job with starting with a certain velocity, let's say 2 meters per second, and then for 2 seconds we travel, and we end at 5 meters per second. The change in velocity is 3 because we go from 2 to 5, so you do 3 meters per second divided by 2 seconds. And that comes out to be 1.5 meters per second squared for our acceleration. The part that people seem to mess up a lot is if we have something that's going, let's say 10,000 meters per second, and it's traveling for 30 seconds, and then it's still going 10,000 meters per second. There was no change in velocity, so that means that the acceleration is 0 meters per second squared. This gets really important in a later video when we talk about F equals ma, because anytime you have an acceleration of 0, that means that the force is also 0. And people seem to really struggle with this concept because they want to think that if we're traveling this fast, we have some force acting on us. But if there's no acceleration, you do not have a force acting on you. So make sure you're very vigilant and looking at the velocity. If there's no change in the velocity, there's no acceleration no matter how fast we're traveling. Now let's break down our 4 kinematic equations. These 2 equations are ones that you really just have to memorize, but the other 2 are ones that you can conceptually understand to the point that you don't have to have them memorized at all. As we break these down, make sure you understand that acceleration is constant for all kinematic equations. Now let's look at this equation first and how to understand it. This entire section of that equation is just taking the average velocity. Since the acceleration is constant, when we go from VI to VF, the velocity directly between those two is your average velocity. And again, that only works if we have a constant acceleration. Let's say, for example, you were traveling at this initial velocity for 29 out of 30 seconds. And then only in that last second did you accelerate up to that final velocity. If that was the case, then the average speed would be way closer to the initial velocity than it is to the final velocity. But if that acceleration is constant, which it always is for kinematic problems, then your average velocity is right between those 2 values. And then once you find that average velocity, all you have to do is multiply it by time to find the distance traveled. And that's just because if you travel, for example, let's say 10 meters per second, which is a velocity, and then we multiply that by, let's say, 5 seconds, then very clearly that means that we traveled 50 meters. So we are just doing the average velocity, which is that entire part of the equation, multiplied by time, which is exactly what we're doing down here. And all of that gives you the distance traveled. Hopefully that makes a lot of sense and makes it to where you don't have to memorize this kinematic equation. Now let's look at this one. And this one should also be pretty easy. For this one, we are saying that we're starting at an initial velocity, and then we are accelerating, which is the change in velocity per time, taking that acceleration and just multiplying it by the seconds that we do that acceleration. So if you accelerate, for example, at 5 meters per second squared, so that means every second your velocity is going up by 5. Then after 2 seconds, your velocity should go up by 10 meters per second. And that's what we're doing with a times t. We're taking the acceleration, multiplying it by how long we accelerated, and then adding that to the velocity that we started with. Back to the example, if we accelerated at 5 meters per second squared, and we did that for 2 seconds, then our velocity should go up by 10. Let's say our initial velocity was 5, we just add that 10 to get a final velocity of 15 meters per second. And that final velocity is what we're trying to find with that equation. So hopefully this equation you don't have to memorize either. If you run into a problem where you have to use one of the other two kinematic equations, my recommendation is that you first list out all of the variables that you're given, and then list out the variable that the question is asking you to find. Then just look at your two kinematic equations and see which one of those happens to have all of those variables involved. If you watch the videos after this, we will apply this approach to a few examples.